Hi everybody and welcome to our wee lesson on series and parallel and chemical cells. So we're going to look at two different types of circuits. We're going to have a look at series circuit and we're going to have a look at parallel circuits. So let's start with series. In a series circuit, the components are connected end to end, one after the other. Remember, the components can be bulbs. So here we've got two bulbs connected one after the other. They make a simple loop for the current to flow around. Now the issue with that is if one bulb blows, which means it goes out, that creates a break in the circuit, and we know if there's a break in the circuit, the current can't flow. The current needs a complete circuit, so all the bulbs go out. We also have parallel circuits. Now the components are here connected one above the other. We can see that in the diagram. Now if we think about the charges, the negative charges, passing round from the negative to the positive, what we're saying here is the current has a choice of routes. It has more than one path. So some of the current will flow through this path and the rest of the current will take this route here. Now this means that if one bulb blows and we've got a break in the circuit, there is still a complete circuit to the other bulb, so the other bulb will stay on. So for example, if this bulb blows, creating a break in the circuit, the current can't flow this way, but it still can flow this route here. We still have a complete circuit for the current to flow. Now how do we measure current? Now from the last lesson we learned that electrical current is measured in amps using an ammeter, and here we have the symbol for an ammeter. So we're going to look at how we measure current in both a series and parallel circuit. So we use an ammeter to measure the current. And we can see from both diagrams that the ammeter, which is here and here, is set up in series with the lamps, with the other components, one after the other. So let's have a look at measuring current in a series circuit. What do we find if we connect ammeters to different points in a series circuit? Well, what we find is the current is the same at all points in a series circuit. And this is because there's only one path for these electrons of the current to travel through. So at each point in a series circuit, the current is the same. If we compare this to a parallel circuit, because there's more than one path, the current splits up. So as I said before, some of the current will go this way and the rest will go this way. So what we find is the current is shared between the components in a parallel circuit. So we can see in the diagram here, we've got 2 amps leaving the negative terminal, 2 amps at this point here, and then the current splits up. And we can see that we've got 1 amp going this way and 1 amp going this way. And then they both rejoin at this position to make your 2 amps, returning to the positive terminal. So let's have a go at this question here. Here we've got a series circuit and a parallel circuit. Now let's take the series circuit first. If I connected an ammeter here and an ammeter here, what would the current likely be? Remember, there's only one path for the current to travel. So if it's going to only have one path to travel, that means the current is going to be the same at each point in the series circuit. Now let's turn our attention to the parallel circuit. Remember, the current's moving from the negative terminal, but we can see we've got more than one path. In fact, the current has 3 different paths it could take. So if I was to set up an ammeter here, what might the current be here? And if I was to set up an ammeter here, what might the current be? Well, if the current has more than one path, the current splits up. So it'll be 1 amp here and 1 amp here, and we can see they all add up to our 3 amps. Now what if I put an ammeter here? Remember, the current has split up and it's all meeting back at this point in the circuit. 3 amps. Let's do some practice. What are the two main types of circuits? Well, we've got series and parallel. So I want you to have a go at drawing a series circuit with a cell and 2 bulbs. Now remember, cell looks like that, and your symbol for bulbs looks like that. And in a series circuit, the components are positioned one after the other. So that would be our cell here, and we would have our 2 bulbs, one after the other. In a series circuit, the components make a simple loop for the... Now what is it that flows round? The current. In a series circuit with 2 bulbs, what would happen to the other bulb if one bulb was to blow and therefore would have a break in the circuit? Well, the other bulb will go out because we've broken the circuit. Now this time we have to draw a parallel circuit with a cell and 2 bulbs. But remember, they're in parallel, so each bulb is behind the other one. Now remember, you can pause this video at any time. So, we would draw a cell, it's a symbol for your cell, and 1 bulb here and 1 bulb here. And we can see that 1 bulb is behind the other. We've drawn 2 paths for the current to take. In a parallel circuit, if 1 bulb blows, there is still a complete what to the other bulb, so in a parallel circuit, if 1 bulb blows, we still have a complete circuit, so the other bulb will stay on. What is an electrical current measured in? Amps. Electric current is measured using an what connected in series in the circuit? An ammeter. Draw a symbol for an ammeter.